This is my second time recording this video today because the first time I think I fat-fingered the keyboard and turned off the microphone instead of pausing the video when my dog started barking. Yay! This is Unit 3, Lesson 5, Reflections about the Origin. A reflection about the origin is when a reflection occurs over both the x and y axes. So it's going both side to side and up to, oh look, it saved all of my little notes. I don't have to draw it again. It's both side to side and up and down, and reflecting about the origin. The origin is located at 0, 0, which is right in the middle of your graph. Let's do a quick review. A horizontal reflection is f of x changing to f of negative x, and it goes over the y-axis. So it's this orange parabola to this blue parabola, okay? That's a horizontal reflection. And notice the x gets the negative because the x values are changing, okay? The y values all stay the same. A vertical reflection is going from this orange one to this green one. It goes over the x-axis, it's up and down. And the f gets the negative when it changes because the y values are changing. Okay, this should be in your notes. Transformation of f of x to negative f of negative x. You negate both the y and the x values by multiplying each value by -1. Before, we only had one change. Here the x changed, here the f changed. Here both f and x are changing. And remember, f is interchangeable with y. The transformation is reflected about the origin. So examine the function f of x is equal to x plus 2 squared. When transformed from f of x to negative f of negative x, the equation becomes, turn on your brain for a minute here, negative f of negative x. This negative f makes the whole problem negative. So we put this negative sign and put everything else in parentheses. Okay? Negative x means each x becomes negative. So we have another negative attached to this x. Okay? This will make more sense as we go along. It's not a huge part of this lesson, don't worry. The graph for the transformation is shown. So this is our original problem, f of x. This is negative f of negative x. It went over the y-axis and over the x-axis. You don't have to do this in a certain order. You could do the x-axis first and then the y, doesn't matter. The transformation negative f of negative x on the graph is created by reflecting over the x-axis and the y-axis, or about the origin. That's another name for it, okay? So this graph has all of these points, and this graph has all of these points. Now this graph is actually wrong. Each of these x's should also have changed. This -2 should become positive, so don't worry too much about these graphs. Example number 1, sketch the reflection of the function f of x is equal to 2x squared to negative f of x, negative f of negative x, and show the reflection in a table. Now, the quick check, which is what you get graded on, does not ask you to graph anything. So I will show you how to graph this using GeoGebra, but don't worry about it for right now. This is what the graph looks like. This is your original. This is f of x. This is negative f of negative x. So you negate both the x and the y values, and you reflect over the x-axis, which flipped it upside down, and the y-axis. So it got flipped side to side. It looks the same, but it did get flipped over. Okay? This is what the table looks like. Your x and f of x values is this orange bit right here. So you go, if you go over to -2 and up 8, there's your first point. Okay? That gets changed. The negative becomes a positive, and the positive becomes a negative. So if we go over 2 and down 8, there's that point. So this point reflected becomes this point. Okay? If you go through your chart, you can see the negative becomes a positive, the positive becomes a negative. Zeros always stay because they're not negative or positive. Positive to negative, positive to negative, positive to negative, positive to negative. All the numbers are the same. The only thing that changed was the positive and negative signs. Here's another example. Sketch the reflection of the function f of x is equal to x cubed to negative f of negative x and show the reflection in a table. This is what your graph is going to look like. When the function is transformed, it doesn't look any different. Okay? Huh? Why? That doesn't make any sense. I'm going to show you. So we have all of our points of our original graph, which is this orange line right here. Okay? If we go over 2 and down 8, there is our first point. If we go over 1, down 1, there's our second point. There's our 0, 0. Over 1, up 1 gives us that point. Over 2, up 8, there's all of our points. Okay? But if you look here, we're changing all of the negatives to positives and all of the positives to negatives. So what happened is this graph is flipped upside down. So -2, -8 is also here. It's just the last point. So this first one started at the bottom and went to the top. So it had a positive slope. This one has a negative slope. It started at the top and went to the bottom. Both lines are here. You can just only see one because they cover the exact same points. The reflection flipped it upside down. Okay. Here's a check-in. What happens to the x and y values when a function is transformed from f of x to -f of -x? Both the x and y values are negated when multiplied by 1. All the numbers in the table, all the points on the graph, get their signs flipped. Here's example number 1. Sketch the reflection of the function f of x is equal to x squared plus x to -f of -x and show the reflection in a table. This is what your graph is going to look like. So our original got flipped over the y-axis and down. Okay, so it got shifted just a little bit. The origin was here and now the vertex was here and now the vertex is over here. It got shifted just a little bit. Here's what the tables look like. Negative becomes positive, positive becomes negative for the whole graph. Okay. Here's another check-in. What happens to the graph of a function when it is transformed from f of x to -f of -x? The function is reflected horizontally over the y-axis and vertically over the x-axis. You can also say that it has been reflected about the origin. There's two ways of saying it. Two reflections or just reflected about the origin. Think about it another way. Note that if you're given the graph of a function f of x, you can also create a graph of -f of -x by first reflecting over the x-axis and then reflecting over the y-axis. Or, this is written wrong, you can reflect over the y-axis and then the x-axis. Okay, you can do it either order, it doesn't matter. Vocabulary review. A horizontal reflection is a reflection over the y-axis only. A vertical reflection is a reflection over the x-axis only. A reflection about the origin is reflections over the x-axis and the y-axis. And the origin is found at 0, 0. This should all be in your notes. All right. Which set, let me grab my little eraser. Which set of equations reflect across the origin? Okay. So we're going from f of x, all of these x minus 5s and x plus 5s and junk don't matter. We're going from f of x to f of -x. No, that only changed 1. F of x to -f of x, only changed 1. F of x to f of -x, no, you only changed 1 again. F of x to -f of -x, bingo, bango. We need to change both. Okay. Now, let me pause this for a second. Okay, I erased all the junk. Identify the graph of f of x is equal to x plus 3 squared and the graph of the reflection about the origin. So we're reflecting about the origin, which means we need to go both directions. This only went horizontally. That's not it. This only went vertically. That's not it. So it has to be one of these. The easiest way to figure it out is to graph this on GeoGebra, which I will show you later in the lesson. This one is the correct answer. Here's question 1. This one's all you. Create a table for the function f of x equals -f of -x, given the following table for f of x. So it gives us this information, and it wants you to make a table for -f of -x. And I already wrote all over it. But it's really simple. All you're going to do is change the signs for everything. All of these are positive, so they're all going to become negative. And look, they did. For -f of -x, each input and output value will be the opposite of the original input value. So positive 2 becomes -2, positive 1 becomes -1 through the whole table. Okay. Sketch the points for the functions f of x and -f of -x based on the tables from question 1. These are the same tables from before. Which function has points that lie in quadrant 1? Which function has points that lie in quadrant 2? So you could graph this, but there's really no point. I mean, it would take forever to go and put in each of these points. we can just do this with common sense. All of these are positive numbers, so they have to be in quadrant 1 because these are positive y values, these are positive x values. All of these are negative, negative x, negative y. So these all go in quadrant 1, these all go in quadrant 3. Remember, this is our first quadrant because it's the easiest. Everything's positive, and then you go clockwise. So this is 1, 2, 3, and this one's 4. Okay? And this just shows you, if you go through and find all of these, this point 6, 7, you would come over 6 and up 7, and look, it's in quadrant 1. This one, if you come over 2 and down 1, look, it's in quadrant 3. Reflection about the origin review. This is all the same information over and over and over. The function is reflected over both the x-axis and the y-axis. The two reflections transform a given function y equals f of x into y equals negative f of negative x. Multiply all outputs and inputs by negative 1. The new graph will be reflected vertically and horizontally. What do you notice about the graph of the reflection? The new function is created by reflecting the original function over both the x-axis and the y-axis. You can visualize this as 2 steps, flipping the image upside down and then reflecting it over the y-axis. All of the x and y values become their opposites because all of the inputs and outputs are multiplied by negative 1. Use the formula xy becomes negative x negative y for a reflection about the origin. This little bit should be in your notes. Here's the 2 graphs full of information. So you can see here our first point is negative 2, 0, which is right there. And over here, our first point would be 2, 0. Okay, easy enough. This one is all you. Question 1. The original function has a minimum value of negative 2, 0. Is that statement true for the transformed function that is reflected about the origin? Well, everything has to change, so this is going to become 2, 0. So no, it's not true. Okay. Question number 2. The original function has only one x-intercept. Is that statement true for the transformed function that is reflected about the origin? My brain doesn't work this way. Maybe yours does. I couldn't answer this one. But yes, the reflected function also has one x-intercept. And that makes sense because let's say that it's just a straight line, okay? If you reflect it about the origin, it's going to be something like that, okay? So it still has only one x-intercept. Question 3, the shape of the original function is a parabola. Is that statement true for the transformed function that is reflected about the origin? Yes, if I have a parabola here, I'm still going to have a parabola here, right? Parabolas don't become something else. Example number 1, describe the transformation of f of x equals x squared plus 4x plus 2 to y equals negative f of negative x. The image shows the graph of f of x in solid line, this orange one, and the graph of negative f of negative x in a dotted line. So they want us to describe this. Okay. The graph of the function f of x is reflected over both the x, so it flipped upside down, and y-axes, it moved over. The equation of the reflected formula. This is where it gets a little complicated. Again, you don't have to do this yet in the lesson. You don't have to do this lesson at all. This is just to get you prepared. So y is changing to f of x, but we're dealing with the negatives now. So we have negative f of negative x. This negative f makes the whole problem negative, okay? So we put a negative and everything in parentheses. And then this negative x makes each x negative, okay? And I think I typed this incorrectly because this should still be positive. Everything else just moves down, okay? In the reflected function, the point xy in the original function is now the point negative x, negative y. This is just showing you how in the formula, we go from x to negative x, y to negative y. Both graphs represent quadratic functions that have a domain of all real numbers. The original function has a range of y is greater than negative 2. So you can see this is its lowest point. So its range is everything above negative 2. The vertex is located at 2, negative 2, and it opens upward. The mirrored image has a range of everything less than 2 because it's been flipped upside down. Its vertex is at negative 2, 2, and it opens downward because it's been reflected about the origin. Here's another check-in. Sally says the only way to describe the transformation from y equals f of x to y equals negative f of negative x is a reflection over both the x-axis and the y-axis. Describe her misconception. Oh, Sally, you've misconstrued it. That's one correct way to describe it. But the other way you can describe it is a reflection about the origin, you silly goose. Oh. Here's example number 2. Identify and describe which transformation of the graph represents y equals negative f of negative x as a reflection of y equals x plus 2 squared. You're going to do this a lot in the quick check and the practice. Okay, this is our original right here. It can't be this one because that just reflected over y. It can't be this one because that just reflected over x. It has to be C. Okay. Here is check-in. If a function lies entirely in quadrant 1 and is reflected over the origin, where will it lie? Explain your reasoning. Well, it has to go over x and over y, so it's going to be in quadrant 3. Ta-da! Here's another review. An exhausting review. A reflection about the origin is when the function is reflected over both the x and y axes. Thus, they transform a given function y equals f of x to y equals negative f of negative x. To reflect a given function about the origin, you multiply all output and inputs by -1. The new graph will be vertically and horizontally reflected. If you don't have all of this information in your notes, you should. Here is question number 1. Describe the function transformation of y equals f of x equals x plus 2 to y equals negative f of x. The negative f goes outside and changes the whole problem. The negative x goes to each x. Okay, now they're showing you how to distribute this negative. So this negative goes to this negative and makes it a positive. This negative goes to this positive and makes it a negative. So your final formula is this x minus 2. Don't worry about it if it didn't make sense now. We'll do it in another lesson. Note any changes in the slope and the y-intercept of the line. Figure it out, pause it, come back. Okay, there is no change in slope. You can see they're parallel. They're never going to touch each other. This is rise 1, run 1. This one is rise 1, run 1. Okay, but you can see the y-intercepts changed. And that's exactly what we should see because it goes from 2 to -2 because everything has the sign change. Okay. Here's question number 2. Identify which graph represents the reflection about the origin of the graph y equals f of x. Okay, here's our original. This you should be able to do. It can't be this one because it only reflected over y. It can't be this one because it only reflected over x. It has to be B. Ta-da! Okay, now we're at the end of the lesson. We will do these together, but I want you to try first on your own. Create a table for the reflection about the origin of the function. F of x is equal to x plus 2 squared plus 1. Hint, first create a table of the values for f of x evaluated at 0, x equals -1, and x equals -2. This is all of the information they give you, but first we need to create our own table for x and f of x values. Okay, so pause the video, do it yourself, come back. We already know that all of these are going to be different, and it tells you right here they're going to be the opposite. 0 stays the same, 1 becomes -1 because everything changes, and 2 becomes -2. All of this makes sense, okay? You're just going to take this formula and you're going to fill in your x values. So our first x value is 0 plus 2 squared plus 1. This becomes, oh, this is f of x, and there's an equals. I'm so good at this. Okay, f of x equals 2 squared plus 1. This becomes 4 plus 1 is 5. Okay, let's erase this garbage because I made a huge mess. Now we'll do our next one, f of x, and our next x value is -1. So we have -1 plus 2 squared plus 1. -1 plus 2 is +1, so 1 squared plus 1. 1 times 1 is 1 plus 1 is 2. Okay, let's do our last one. We have, give me my marker, f of x. Woohoo, that's beautiful. Yeah, you do that. F of x is equal to -2 plus 2 squared plus 1. Negative 2 plus 2 becomes 0. 0 squared is 0 plus 1 is 1. Now guess what? This one's really easy because we just flipped the sign, so it's negative 5, negative 2, negative 1. And that is your final answer. This is a negative. All right. Here's practice question number 2. And look at that, I already wrote the answer in. Okay, but it shouldn't be hard. Reflect the function f of x equals x plus 1 squared about the origin. What is the position of the point negative 4, 9 in the reflected function? Speed round. Boo, 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 boo. What is it going to be? Oh my gosh, it's easy. You just flip the signs. It's 4 and negative 9. Wow, aren't you a smarty pants? Here's practice question 3. Complete the table to show that h of x is the reflection of about the origin of the function f of x. Again, you know, speed round, you can do this. Positive 1 becomes negative 1. Positive 1 becomes negative 1. Positive 2 becomes negative 2. Positive 8 becomes negative squirrel. Negative 8. Okay. If the function y equals x squared minus 4 is reflected about the origin, which of the following is true regarding the number of x-intercepts of the reflected function? Hint, sketch a graph of the function y equals x squared minus 4, then sketch a graph of the function reflected about the origin. Guess what? You don't need to do... Oh, no, this one you do need to do. This is the one where I went to GeoGebra and did it, so we'll do that. I didn't talk on the GeoGebra one. I'm just using the one that I recorded before, that the microphone was muted. But you can clearly see from the GeoGebra one that it had 2 intercepts. It had 2 intercepts in the first one. It had 2 intercepts in the second one. And here is practice question number 5. Given the graph of f of x is equal to the square root of x minus 1 plus 1, which option shows the reflection of the graph about the origin? Here's our original. It's not this one because it only flipped over the x-axis. It's not this one because it only flipped over the y-axis. It's this one. Here is the quick check, and I will walk you through how to find the answer, but I will not tell you the answer. The function f of x is equal to 2 times x plus 2 squared is shown in the graph, which table shows that g of x is equal to negative f of negative x, results in a reflection about the origin of the function graphed. Hint, make a table of the x and y coordinates based on the graph. Use these points to determine the coordinates of the function reflected about the origin. So I just went through and made a table of this graph. So our first one is negative 3 and 2, and then we have negative 2, 0, and then we have negative 1 and 2. This is the table for this graph. You need to find the table for the reflected graph on this page. Okay, don't overthink it. Here's quick check question number 2. Which of the following is the vertex of y equals negative f of negative x if the original function has a vertex of negative 9, negative 8. Don't overthink it. This is a speed round. Boo, boo, boo. Quick check question number 3. Choose the statement that best describes a true relationship between any point on f of x and negative f of negative x. So if you have x, y on the graph f of x, then what are you going to have on the graph negative f of negative x? You should know this by now. Quick check question number 4. If the point 743 is on the graph f of x, what point must be on the graph negative f of negative x? Speed round. Boo, boo, boo. Don't overthink it. And here is quick check question number 5. Describe the transformation of the graph. F of x is equal to sine x plus 2 to the graph labeled option 2. Okay, so this is the original graph. You need to figure out which one is the reflection about the origin. They worded this really stupid. Which one is the reflection about the origin? Speed round. Don't overthink it. And thank you. Thank you for surviving. Thank you for watching. Thank you for existing. Thank you for, not having a math brain either. Goodbye.